Hello, good morning. Thanks so much for joining me here in my shop. It's Monday, April 18th. And so I've been thinking a little bit about this radio since yesterday when I kind of checked it out carefully. Reminded myself that in fact I did an earlier video I'd forgotten about where I tested the tubes and determined that this tube was a bad actor. That's the FM tube. But the interesting thing I think that is going on with this radio is when I had it playing and I pushed the FM button, the magic eye disappeared completely. And I think that's an interesting observation. I think it's an important observation too. Just off the top of my head, it makes me think that pushing the FM button places a short circuit on the high voltage circuits in the radio, enough to deplete the B plus here, so this just goes out. That's my theory anyway. I don't know if that's true or not. Perhaps it's remotely possible there's a short in the FM tube here, but I don't think so. I think it'd be an interesting troubleshooting experience to go on and try to hunt down what is happening when you push this FM button and this is forced to go out. I think that might be an interesting journey, and I think that's probably the first place to go with that is maybe the schematic and study the circuitry, especially around this push button, to see, because in a lot of radios when you turn on the FM you deplete the B plus to other tubes. I don't think that happens in this radio, but I'm willing to bet that when you have the radio not on FM, there's no plate voltage on that tube. That's my guess. And so pushing the FM button applies the plate voltage, and then there's something wrong in the plate voltage, a plate circuit, that's causing a short, drawing down the B plus, which is visible on here. It would be going down on all these tubes. And if I remember right, and maybe I don't, when the FM button was pushed, the radio was silent. But maybe that's a false memory. You know, it's better to have false memories than no memories at all. It seems like that's where I'm headed sometimes. No memories. Okay, so I'm going to try to find a schematic for this guy, and hopefully we can run down through the B plus circuits and find something interesting to investigate. Okay, so I think I found the correct schematic for this radio. So it's a two-pager. This is the left half of the schematic here, but I think we should probably look at the power supply first. This is the FM tube we'll be interested in a minute, but let's look at the power supply. This is the other page. Zoom in a little bit here. So this is the power transformer in the radio. This is the plug you plug in the wall. This is the primary side, secondary sides. This is running to the heaters and the light, the one light bulb. And this is the high voltage output going through the rectifier. And it gets interesting from here. Out it comes. Notice there's two levels here, 262 and 260. Slightly higher current on the 260. So I haven't noticed it yet, but one of these boxes, probably this top one, is an AM shortwave setting, and this is the FM setting here. So it's drawing a little more current and pulling the voltage down just a little bit if the FM section's working right. And I believe what's happening is when you push it into FM, this voltage drops right down, maybe even right to zero. So we come out of here, we encounter a filter capacitor. It's like 100 microfarads. Up through the output, speaker output transformer. We reach the plate of the output tube. Okay, and coming across here, that's a 1.5K resistor, probably a higher wattage one. Coming to the other filter capacitor. This is a more filtered line, if you like, less hum here. Gets on, fires up the screen, the output tube, and look, it carries on carries on over here to the plate of this tube, the tryout part here. And then it carries on into a switch. And what this switch is doing. So it looks like it this is a phono switch here, something to do with phono perhaps. Is there a phono button on here? Yes, there is. So if you push the phono button, I'm going to guess it cuts off B plus to the rest of the radio. So this tube and the others on the other page are no longer connected. That's interesting. I would guess then if you say if you push the FM button and the phono at the same time, well, you're not supposed to do that. But if you did, this switch would open and there'd be nothing. I'm going to guess what happens to the magic eye here. Must be on the other page. So we'll follow on. So you can see the B plus is on this top line up here. And there's something coming along down here too. Top and bottom. Top and bottom. So here's the top. This would have to be the bottom. Oh, so the bottom is going to the magic eye. So that's the plate feed, and let me go back. The plate feed is beyond the switch. So when you switch on to phono, the B plus to the magic eye disappears. So the magic eye should go out. It's not doing anything anyway when you play phono. You leave the heater on though, but would make the display disappear. Okay, so we follow along here. It's B plus. Oh, it's kind of circuitous. It comes down here. Back up through these coils. Do you see how it's kind of zigzagged on the way up through the coils there? Comes along, reaches the plate here. Okay, go a little further and voila. I bet you this is the FM switch. So these switches are shown in a certain position. Does it say? It probably says it in German somewhere. Noticed it. I'm looking for a note on here that says switch is shown in certain position. Well, let's see, what position would this be? Let's start from the plate of the FM tube. We'll start from this one here. Comes up. Okay, comes through the coil, comes down here, comes through here. I don't really know what these are, but there's something. Up they come. There it is. Comes up. So for the radio to operate, this switch would have to be in the other position. So it must be in the AM position here. But if you pushed it up, assuming this is the FM button you're pushing, this goes up and supplies B plus through another circuitous route over to here. So both halves of the tube are turned on at that point. So this implicates any component over here that is connected to this B plus line, if my theory is correct. So now we're going to look for things that are hooked up to the B plus line that are grounded. There's a radio, there's a capacitor right here. A resistor I wouldn't worry so much about. This capacitor is very suspicious now. Unfortunately, you see the dotted line here indicates the extent of the FM metal box that the FM components, the RF components are in. So this guy is inside the box. We'd have to do some proving before going after it, because going in this box here presents problems. For me, anyway. Coming in, let's see if there's something else. So we have this guy. This one, if this were shorted,
It's right to ground. If this one were shorted, it would pull current through this coil. If it pulled so much current that it burned this coil out, if that's possible, probably not possible, but if it is possible, you know what, it's on the other side of this big resistor here. All these are on the other side of this. Zoom in, I can't see what I'm doing. Make use of the computer, Jim. Okay, 10K, 10,000 ohm resistor here. So plate current is passing this way anyway through a 10,000 ohm resistor. You gotta wonder if a short here could pull the B plus down enough to shut off the magic eye. So let's follow the other route here. This is a 2,000 ohm resistor. On the other side, here's a capacitor right to chassis. So here's another one that if this were to short, you'd be pulling current through this resistor. A 2,000 ohm resistor on a B plus line, I couldn't really say for sure, but I would have to imagine this would sink a lot of current and just pull the supply down. It's all just theoretical. Now we can do some testing here. One of the things we could do, which is kind of simple, is get on the plate of the magic eye where I think the voltage is dropping, I don't want to operate the radio, so I put an ohm meter on here, push the FM button and watch what happens. That sounds like a piece of information that might be interesting to get, easy to get. I think pin 6, let's try that. We'll go pin 6 on the magic eye. Did you lose your B plus when the FM button was pushed? That's the question. Pin 6.
Okay, well the magic eye socket is sticking right up. Couldn't get any easier than that. I'm going to get out my almost spanky new Allen meter. Thank you, Alan, for this meter. It's proven itself already a couple of times for me. Not necessarily on videos either, but I do other stuff. So we're going to put this on. Well, let's start with 600,000 ohms. Lovely. Pin number 6 up here. There's the gap. So we go 1, 2, 3, 4, 5, 6. The blue wire. No buttons pushed, so the set is off. What do we get? Oops. There could be a table of these resistances. Well, there's a pretty good hunk of resistance there. Looks like it's going to work its way up. I bet you it's going to go to 400,000 at least. But yeah, let's push the FM button. There's that resistor. 2.2. That can't be correct, can it? You have a B plus system running at 500,000 ohms. And then push FM. Let's push another. Let's push this one. See what I get here. Whoops. Okay. It's going to go high again, where you would expect it. Broadcaster should be the same. Just carrying on. Phono. Phono might give you infinite. Yeah, there you are. It's wide open because we saw when you push phono, a switch opens and there's no B plus to the tubes, including this guy. So you know what? This is really, put it back on FM. This is really pointing at that resistor. It's pointing at the capacitor beyond that resistor. Let's pull this tube out of here. For sure the capacitor is inside this box. The place I don't like to go. Okay, with the tube out, what do we get? It's exactly the same thing. No surprise there. How could the two make a difference, really? Well, so my options in front of me are start replacing capacitors willy-nilly, or go after the problem in the box. Probably be better to go after the worst thing. You know, ever since I was a kid, when I go to eat dinner, I have my plate. This is my dinner plate here, and I have the food on it, and I have different feelings about the different food on there. But one of them, maybe I really like. I really like one bit of food on my plate. I will eat through the stuff I don't like first before I get to the stuff that I like. That's me. I don't go after the stuff I like and then get... Same thing, say, when I'm doing a painting job or something. I'll look at the situation and go, oh, the worst area to paint is there. I'll start there. That's to get it out of the way. Get it out of the way. In this case, it's much more practical. Not much use in doing a lot of work on this radio over here if the problem's in here and I can't resolve it. And so the FM in this radio is dead. That'd be time for me to say to the owner of the radio, you know, do you really want anything done to this? Because if there's no FM, you know what, you're going to listen to AM radio? Who's listening to AM radio these days? Somebody is, because man, there's a lot of AM radio stations. And have you ever noticed that once a radio station's set up, once it's operating, it never goes away? It must be easy to make money with radio stations. That's all I can conclude. Doesn't seem to me that it would be easy, but they never go away. Maybe in the background they're changing ownership and I don't realize it, but the station continues all the time. Man, if I'd only known that. Think of all the things as you get older that if I only knew this when I was younger, I'd be a millionaire now. Probably not. Okay, we're going to have to go after this part. Now, seldom have I ever disconnected this stuff here. I'm just looking at the little screws here. This top plate is continuous down to the side. Looks like there's just a screw there, screw there. So basically, these two, and then this whole top piece is going to come off. And there is a problem. This connection here is going to be in the way. I'll have to desolder this, remove the cable. This is the output from the tuner. A lot of business going on in here. Output comes out here and heads off to the rest of the radio. The stuff that's going on inside this box is all at high frequency, the same frequency you're tuning at. So if you're tuning in 100 megahertz, 100 megahertz running around inside there. But one of the things that happens in there is the 100 megahertz is converted down to 10.7 megahertz, much lower. And then the 10.7 comes out of here. You don't need to be so concerned about the environment. You don't need to have it in a box. So out pops the 10.7. So let's get this off. Let us get this off. Funny how I talk like I'm not alone. I'm alone here. So if you're new to watching my videos, while we wait a few seconds for the soldering iron to warm up, one of the things I'm doing while I'm working on these things is I'm looking for an interesting, fun way forward. And I'm not doing that because I'm doing that for a very practical reason. If you're not keeping the fun level high while you're doing this work, it will kill you. Kill you dead. There's lots of ways to get frustrated doing this work. So you have to balance against it. So that's why I do a lot of things the way I do them. What did I do? You know what I did? I reached over and I turned on the DC power supply over there. I didn't turn on the soldering iron. I have a hard time doing anything with a ice cold soldering iron. And talking about cold, it's kind of cold outside. Lots of areas around Ontario have snow. Not right here. The sun is shining here. The place I live, Aurelia, has a nickname, the Sunshine City or something like that. It's not the sunniest place in Ontario or Canada, but it's definitely up there. And it certainly is sunny here a lot. That's my DC power supply I turned on by accident. There we are. Ooh, that's a long piece of wire there. Bend them out of the way. Go over there. Didn't want to go. Okay. So this is something I'm not that familiar with doing. I don't know if I've ever actually... that's not good. I don't know if I've ever dug in so deep. This looks too small. Ah. Okay, I'm gonna have to get out my another set of tools here. I don't think I have a. I don't think I have one that's coming on. I have to get some other tools for this. One of the things that's frustrating about living in Canada here, for people doing this kind of stuff, or just about anything, I thought that fit. Did I grab the wrong one? Is that I live in a mixed metric and non-metric environment. Oh, that doesn't fit. I thought I had one here that fit. There it is. So the way it works for me is I never know what I'm doing. I don't know if it's metric. I don't know if it's imperial. My tools are mixed up. I kind of look at it and say, this is 7/30 seconds. So this is a non-metric. Imperial. It's not quite the right size, is it? Good enough, though. Anyway, that's always been a frustration. You never know what you're dealing with. That's how it seems to me. Just being silly. I like to blame it on our neighbors to the south. They seem to like the imperial system. Think about that for a bit. What imperial system are you talking about? Okay, let's see if we can get this off now. A nice place to pry. That's not one of them. That's definitely not one. What's going on with this? What's the story with this? Don't know why I would take that off. It looks to me like the intention was to put this on, twist this to lock it on, and that's the end of that. And they didn't twist it. That's what it looks like. I need a much bigger, I have a big honking screwdriver here. Big honker. Pop off. Oh, one more screw. That's why it's not popping off. Why they put 3 screws on this side. Those tricky guys. Now I better put these in the cup. Not leave them on my bench. Okay. Now this will probably come off. Yeah, here it comes. What goes on here? What does go on there? Let me put this up again. Break it. Well, I think this has to come off. That's for. But I don't use it. It's supposed to be for another radio. Put it in the cup. pop, pop. Ta-da! Well, I don't know, that's not quite as bad as I kind of thought. So we got to figure out which capacitor it is, and then test across it. Where's there a capacitor in there? Holy smokes. So there are some things in here I have trouble identifying. I'm never so sure about all these guys here. And that resistor has a coil wound around it. All these parts are in a position that they need to be in. When I go to change one of these parts, I'm going to disturb the arrangement here, the physical arrangement of the components. There is the part I'm after down under here. Is that possible? Oh, it's possible. I just looked in here. It is more than possible that the parts I'm after, buried way in here. Oh. Oh my. Hope not. You know, I shouldn't be too upset just yet. Okay, which one of you guys is causing trouble? Maybe I can identify it by the resistor. The resistor was a 2.2K, so it'd be red, red, orange. Red, red, orange. Yeah, and I'm just too stupid to know for sure if this is a capacitor or a resistor. A little scary fooling around in here. As long as I don't touch anything, we're okay. The moment I start doing something, I'll go back to oh, there's a resistor down under there, hidden away. They hid it. Is that the guy? It's got a green. No, can't be the guy. Not with a green. Oh, that one is. That's brown, red, brown. It looks like the coil around it. Uh-oh. It doesn't seem to be topside. I don't like where this is going. So another set of terminals are over here. If I want to lift this part up to get underneath, what do I have to do? You see they have a little tab coming through here. So it looks like you probably release the board and pull it back. And there's a pile of stuff under there. Okay. And is there by some chance a 2K resistor hanging around here? The diagram is fairly explicit about where these parts are, whether they're inside the box or outside. Well, and then, so what releases this? How do you get this whole thing up? I hope this isn't the 2K resistor underneath that coil. Okay, that's just a coil. Here's another coil that could have a resistor in there, but I don't know. We have to find a 2.2K resistor. Wandering around is not going to find it. We have to figure out how do you get this off. Oh. Hold the fort. Hold the fort. I don't want to get this board off because look at it, it's hooked up to all this stuff. The string, the wheel. Oh my gosh, right. It's the tuning box. Oh my gosh. Okay, don't panic. Maybe it's up on top here and I just haven't seen it yet. And maybe it's not even the capacitor I'm trying to hunt down. I'm just plainly wrong. Well, it's not so plain. Okay, I'm going around in circles. Study the schematic some more. Maybe there's some part layout diagrams somewhere that I can scare up. I don't know. I don't know. Yeah, the other radios I was working on, they had part layouts for the inside of this tuner box. I think it's the very, very same tuner. Because there were two adjustments there, one here, two capacitors there, and two adjustments here. This is the very, very same tuner. Those sneaky radio manufacturers. These things pull out. They don't pull out, do they? No. What's going on here is they have a little carbon sleeve on them here, I think. No, maybe not. I don't know what's happening. What's happening? It almost looked like you pull them out, but I don't think so. Yeah, it gets back to lifting the board, and you can't lift the board without dealing with all this. Yikes! See, this is why I wanted to check into this, because I may be saying to the owner, the game's already lost. They haven't even got anywhere. The reason I would say that is removing all this, something I've never done, getting involved with the string, yikes, there's a really good chance it just wouldn't be successful in the end. For various reasons, not the least of which is making mistakes, putting it back together, breaking something on the way out. There's a whole list of ways to get into a jackpot with this. Okay, I'm going to study the information, see if I can find some kind of hint on where is this capacitor physically located, or the resistor. Okay, I got a bit of luck here. This is the diagram, the component layout diagram for another Nordmende radio, pretty much identical to this one, and as I was mentioning, looks to me like all these tuners are exactly the same. So sure enough, this is from the Caruso C radio, and if you look, all the components are laid out exactly the same. This part here, this part here, you have this one coming across, there it is coming across. Got this guy with a coil up on the corner of this little board, there he is there. It's identical. That should make it easy, because I just have to look on the schematic, get the part number, and then look on here for the part number, except no. Because this diagram, I'm pretty sure, was not made by Nordmende. This was made by, and I've forgotten their names now, a company which specialized in making schematics up. They would get the actual radio, study it, and create their own schematic information from it. That way, they weren't stealing copyrighted information, or so I understand. Maybe I got that story wrong. So the result is, these component numbers, like R6, don't match the schematic I have. But I have the parts list here, so I could find the right part in the parts list, the right value, go, okay, that's R something or other, and find it here, okay, R something or other, and then find it here. Except, I don't have the proper parts list here. There's no resistors on this part of the parts list. I'd have to find some more parts lists here. Okay, I think I've got it somewhere. I can find it. Okay, so I found the parts list that goes with that diagram for the Caruso C radio. 60 resistors in there. There's a 2200, and there's no other 2200, which is great.
So this must be it then, R6. So we'll look on that other diagram for R6.
Okay, is there an R6? Oh, yes, there is right here. R6 was right here in my face. This one. Well, that's not 2200. That's 20. That's a 2 ohm. Everything just fell apart. And look, it's a very different looking resistor. The soldering looks fairly new. What is up with that? Let me get this out of the way. The bright page, when I bring a bright page in, my camera adjusts. Well, what's the story on this? So if this is the resistor in question, it's a high wattage resistor. Am I reading this right? 2 ohms? Wait a minute. Am I going the wrong way? This is an orange band? Quick to the Allen meter. Where is it here? We will go way down here. 600 ohms. Oddly enough, 6,000 scale. Just under 1,000 ohms. Well, this could be in a circuit. Maybe that's why I'm reading that. Is that the resistor or not? The puzzle just keeps puzzling. It looks like it's been replaced. It looks like it's the wrong one. It looks like it just doesn't look like it's very likely I've got this straight here. So the capacitor would have to be connected to this resistor. So we go this way to a coil, and then further variable capacitor, a trimmer here. We go this way, we don't know what's happening. It's disappearing underneath. And yikes. So red wire here. Let's look a little closer and see what is up. Well, it sure looks like it ties to the red wire. And the red wire goes way over here. And then goes off as an orange wire. Well, these are probably incoming voltage supplies. It'd be great if it's that capacitor right there. Then rejoice. We could rejoice at that. Huh. Is there anything else connected there? I just see a wire. That comes around to the back. Yeah. That would put the capacitor potentially inside behind that pin way back there somewhere. Neverland. Boy, oh boy. So some of these wires that are connected up here have play in them. But some of them don't, like these ones don't. Like going down to the chassis here. Just thinking more about, you have to lift this and remove it. What do you got to do to it? Smash it with a hammer. Work with the pieces. I don't think these screws are involved down here, right? They're holding the can. I mean, you gotta lift the whole can off and then get at fasteners underneath. There's even more stuff, is there? Down way down below? Oh my gosh, how do you deal with that? Looks like there's some kind of tab sticking out. Something soldered to it. Yes, do not rush in here. Russian? Russian? Did I say Russian? Well, so if this isn't it, where is it? Okay, I don't know. I don't know what to think. I gotta. If I measured this, I got 1,000 ohms on it. So if this is a red, black, black, unless I've lost my mind, it's 2 followed by nothing, followed by nothing. It's 2 ohms. But I read 1,000. You can't read 1,000 across a 2 ohm resistor no matter what. Let me repeat that measurement. Could it be the fault of the Allen meter? The Allen meter says nope. Okay, here we go again. That's the same reading, 1,000. I'm on the 6,000 scale. It says right up there, K volts, K ohms rather, K ohms. Well, that's quite a mystery. Then how does a 2 ohm resistor get 1,000? It opens. It's open. It's open and the 1,000 is something else. Wow, okay, this puzzle's really gotten difficult here. Just to review again. Make sure the confusion's really clear. This looks like it's been soldered in separately from the manufacturing process. I look at all the other solder spots, they are dust covered. These two are not dust covered. This resistor looks different than any other resistor you find in the radio. Looks different than all the resistors in here. Looks different than the diagram I was waving around earlier. It's possible the capacitor shorted and burned the original resistor out. And some guy stuck this one in. He stuck in a higher wattage resistor thinking that'll, take the heat. Maybe that's not a good idea. Sometimes it's a good news when the resistor burns out, because if the resistor doesn't burn out, something else is going to burn out. So occasionally these act like fuses in a way. You could burn a resistor out. You've got the whole B plus power supply pushing on it if there's a short on the capacitor. Capacitor I can't find. Don't know where it is yet. Wait a minute, why don't I look for the capacitor directly? I'll do the same thing. Yeah, that's how you add to the confusion. Okay, let's go back to the schematic here. Okay, hold the horses for a minute now. When I did the test on the plate of the tube over here, I ended up with a reading of 2,200 ohms. Exactly what I suspected, exactly what this resistor shows. And well, when I read the resistor directly, the one that I suspect is this resistor, I don't get 2,200, I get 1,000, and some mystery with it. So I may not have got the right resistor there. R59. Okay, so let's try this. Oh, look at that. Interesting enough, 2,200 again. But I bet you there's a bunch of 2,200s in this radio. So C62,
2200. Okay, so we look at the parts diagram. I think it's here. And we're looking for that. Oh, it's on the paper. It's on the paper. Okay, back to the paper.
C57 2200. 2200. So what we're doing, we're trying to look through this. I'm sorry, this is so small. I can be able to read it. 2200. 2200. Electrolytic capacitors, fixed capacitors. These got to go with this. There's a 0.0022. What is that? That's 2.2 nanofarads, or 2200. That's a 2200 there. Okay, so we got a 2200 C10. C10. Okay, appears to be pointing under the board, right where the mystery resistor is, right under this thing. Okay, let's go looking for it there. See what we can find. Okay, 2200 under the board. We're coming for you here. So there's the mystery resistor and its terminal, and attached to it is this dog bone. Must be a capacitor. Wow, that's easy to access. That's right there. I can stick my finger on it. I can almost stick my finger on it. Let's put the ohm meter on that. See if it's a short. Good idea. Very good idea. Okay. Up here. No, that's no short showing there. 1600 ohms. I'm still not sure what I'm seeing. You'd think after all these years of working on radios, I'd know a resistor from a capacitor. Well, if this is the right resistor, then the other end of it is heading somewhere. If I remember right, without looking, it was heading to a B plus connection. That's probably what this is. It's got reddish colored wires coming to it. One of them goes under, comes up, connects here. All B plus must pass through here. I have the FM button depressed on the radio. Is that going to make a difference? Does that make a difference? It's going to connect the B plus that way. Or another way of looking at it is if I pop the button up, there's no B plus connection back. Maybe just freeze this resistor up for a test. I'm trying to use the hands-free, exactly the same number. So it's 1000 ohms here. Would look like the capacitor's down there. Didn't see a short. Let me try it again. Okay, buddy. Here and here. There's the 1500.
I would expect a 0 on the theory. Two of them in series. Get the sum of the two. Well, is it possible that this is a partially shorted capacitor? I'm starting to really stretch it. Let's try. So I'm pretty sure these are all capacitors here. All these little guys. That big dog bone thing. If I read across what I think are capacitors. Well, again, it's in the circuit, so you can't really be sure what I'm doing. I'm trying to convince myself what these are. So this shows as a, let's put this up higher, 600K. There's another one I can go across. Yeah, so I'm getting open circuit on those, so I'm pretty sure these have got to be capacitors. But that thing underneath is a little bit different looking. Clearly, it's coffee break time. Clearly. Okay, let's try this again. So, red, black, black, with a brownish, goldy, orange color at the end here. I don't know what to make of that. So if this is being read this way, this is going to be 2, 0 with nothing more. It says 20. There should be a 20 ohm resistor here. But when I read it, it's about 1,000. Yeah, I don't see how you can get 1,000 out of this banding no matter. Well, if you go the other way. No. You'd need brown, black, red. Brown, black, red. I don't get it. I'm very close to just desoldering this and measuring it again to see what it comes out to. But I'm going to look at the parts list and try to see if there's a 20 ohm resistor, and that's just like a 1 watt resistor there. You know, it's, yeah, okay, 1 watt resistor. I'm going to look. So I feel like I've hit an impasse, so I'm going to get some more information. So just thinking about it, if there is a short on the plate circuit, then measuring the resistance of the plate circuit to the chassis might reveal something. So this tube's got two separate plates in it. One is in pin 7, that's here. Let me check around here first. Okay, getting a 0. Pin 7. I think it wants to show 200 ohms. Probably just having some trouble making contact in there. 200 ohms, eh? That's the lowest I saw. Actually, I can go right on the pin here. 210 ohms. And the other plate is right here. 0. 0 on the plate. Really? If I made it more sensitive. That's pretty much a 0 there. So pin 6, the plate on pin 6 is showing a 0 to the chassis. That can't be good. Let's check out the schematic here. Okay, so the one tube is showing split here, and this is pin 6. We were getting a 0 here. How do you get a 0 here? You got a resistor in the way. It says 120 ohms. And a coil here could have much lower resistance. So that would get you, so you can't go this way. There's a capacitor there unless this is the problem. Let's go this way. Come down here. We got some adjustable capacitors. The gained trimmer. Wow. Okay, but assuming there's no short there, we would then come through this coil. Look where we end up. We end up right here, where I think this capacitor is shorted. And although it doesn't seem to be when I test it, and I think this is the mystery resistor. Okay, thinking about this a little more. Maybe my story about this resistor is true. Somebody replaced it. And what's going on, I don't know for sure. But this end appears to be connected to B+. That would mean if I lifted this end, or lift this end, either end, I would interrupt the circuit that appears to have the short. The short, theoretically, is on the capacitor under here. So this would remove the short, and then pushing the FM button would no longer what? So I could hook up my ohm meter over here. No, this will always have the short on it. I want to hook up the ohm meter. We'll hook it up on the magic eye. Hook it up on the magic eye. Open this. Push the FM button. Not quite in that order. And see what happens. I think that'll just help further prove the case here. You know, I'm kind of in that boat where I'm not sure what to do, so I'm gonna do something. So we want to hook up the ohm meter here. I'm going to use clip leads. I'll hook it up right on here. So it was from here to where? Is it getting long? It's noon. I'm getting worn out. So this is where I was reading the 2200. Was it the chassis I was doing that? That's right, because I thought I was reading through the hello. Oh, push the FM button. Why the craziness? I got a nice 2.2 here last time. There we are. That's settling in. 2.5. That has nothing to do with 2.2. That's another misnomer on my part. So there is a resistance here on the plate circuit to the chassis of 2.5K. But then when I switch to the broadcast, it goes way up. This is why I got this number. Really? Wait a minute. Thank you, clip lead. Boom, it still shows open circuit. What's happening here? I'm just touching the chassis with this lead. What is happening? Yeah, I think I'm wearing myself out. Is this really the right pin? Blue wire, I remember blue wire. Get on there. Eight megohms. Short wave shouldn't make a difference. FM. It's just not steady, not stable. Oh, there's a 0. I'm using a lousy clip lead. I test my clip leads before I use them. I'm forever testing them. You just can't assume anything. It's just fine. Maybe it was the connection. Get on there.
Okay, so reading to the chassis. We have a 0. I'm way up on this high scale here. Here comes what I thought was 2.2, but it's really more like 2.5. So there's 2.5. But if we go back to broadcast, it's up in the range that you would expect. In fact, it's higher than I would ever expect. So 30 megohms, that sounds crazy, but quite a difference anyway. So I'm not worrying about what happens in broadcast because I've only got so much capacity in my brain here, putting too much stuff in it. There is the 2.4. Now the idea would be I'd lift that resistor and repeat this test. And this would go away. This would be back to the high reading, same as a broadcast. Okay, I'm going to do that. I'm going to do that. I'm going to lift this end of this resistor here out of there. Oops. It developed a very, very stiff neck here. Too much tension. Too much tension in the shop. I got a couple of opportunities now. One is to test that resistor all by its lonesome. Let's do that. What do you say now, resistor? Same thing. Oh, you can't see it. 1,000 ohms. Same thing. 1,000 ohms on a resistor. I don't know how you get there with this, with these numbers, with these colors. Okay, now we look for the short. Go back on here. Radio switch to FM. Let's go back to broadcast first. Make sure everything is copacetic. I gotta go all the way to the top here. 40 million, 35, 30, 25. Seems a little lower. Now we push FM, and it should just stay where it is, more or less. And that's exactly what it's doing. Oh, for crying out loud. There's the odometer here. Missing all the exciting numbers. Oh my gosh, the backlight came on. And you can't really see it there. So that was 2.4. Now it's 8. 2.4, but it was 2.4 thousand ohms. This is 8 million ohms. Right. So let me go back to broadcast. See, it just stayed the way it was. Oh, the backlight's a problem on this meter. Making movies. Well, that once again, that just goes to show I'm right on the money here. The theory is holding up. I just can't seem to sort it out in terms of the actual parts. See, I've got this thing separated now. So this goes to a capacitor. The capacitor goes off some other places, but also goes to ground. Yeah, one side is grounded. Well, that'd be the other side from where the resistor's connected. Can I find that? Okay, let's clip this onto ground. Okay, that's grounded. Check a little bit here. Don't come on, backlight. Okay. What triggers the backlight? Must be shaking the meter around enough. Okay, checking again. We got a 0. We have a 0. I'm way up on 60 million. Let's go for 6,000. Okay, we got a 0. Really This clip lead really doesn't do the trick. Okay, got a 0. The open end of the resistor over here. We get basically the resistance number. Isn't that what that is? Okay, now we'll go on one end of the supposed capacitor. There's a 0 there. And the other end of the supposed capacitor, $1,600. So you get 1,600. This is actually one end of the resistor. I'll go to the other end. This is the end I opened. We get the 20, 25. We get the 25. We will get to 25. There it is, the 25. So does this all add up? So you get 25 here. On a 1,000 ohm resistor, that leaves 1,500 on the other end. We get 1,500? Yes, we do. Is that a 1,500 ohm dog bone resistor under here, or is it a shorted capacitor? So this terminal is also connected right to this coil. I look back at the schematic here. Okay, so here's the mystery resistor, and it's connected to only two things: a coil, which you can see above the board, and then below the board a thing which must be a capacitor. When I read from here to here, I get a reading of 1,500 ohms. Now how can you get 1,500 ohms between here and here, or here and the chassis? So if you go this way, can you make it to the chassis? You're blocked, blocked, blocked. Two things to a tube. It's not even in the socket. You're blocked this way, and then out here you're blocked this way. You have a capacitor here that's working like a resistor. This capacitor has become a 1,500 ohm resistor. Tough to do something about this because of its location. So I'd want to get in there and monkey around again. These parts are like, this is all frequency critical stuff. So if I pull that one out and find out it's bad, I stick in my own 2200. It's a different style of capacitor. You gotta throw this whole thing off. Something terrible. So I don't want to make a mistake here. I gotta know this is bad before I really get in there and do something. Tomorrow, most likely, I'll try to disconnect one leg of the supposed capacitor under here and be able to test the capacitor independent. What if I get a resistance reading? I'll be scratching my head. Is it really the capacitor? Is it really a capacitor? And you can just see that this C10 0.0022. Well, that's what's on the schematic. What's the right size capacitor? That's got to be the case. It's got to be a partially shorted capacitor. Maybe a partially shorted capacitor messed up this resistor. Somebody came in, saw the burned resistor, grabbed one that they had, stuck it in, and go, it's close enough. Stick it in, put a higher wattage one in, stick it in. Now this isn't burning up because it's a higher wattage, because I did notice on the resistor list the wattage is a 0.3 watt. It's a little tiny resistor like the rest of them in here. So we stuck this in, and it's standing up to the current that's going through it. Getting warm, but not burning out. But then they wonder, oh, what happened? I replaced the burned out resistor, but the radio never started working again. And then they sold it to the person who bought it, who's giving it to me. something like that. That's my story. It all seems to add up. It all seems to add up. But it's for tomorrow to really find out. I think I'm going to leave it. Okay, so again, thanks a lot for watching. I hope you find these things interesting. I'm doing this stuff live. I'm just winging it. Just doing my best to find the puzzle pieces and stick them together and come up with some kind of picture that I can act on and not take any undue risks or the like. Anyway, thanks a lot for watching. And the sun is still shining outside. Fantastic. See ya.